Hi and welcome back. So in the past video, we were taking a look at this problem where we had said that consider that we had the set of every single rectangle that we could possibly have, whose area was equal to 100. And what we are trying to find is we are trying to figure out which rectangle in that whole set has got the smallest perimeter. So in the past few videos, we figured out, and we had some arbitrary rectangle where we had a height of x and a width of y. And we said that our area was going to be x times y, and we knew that that was going to be 100. And so from that, we could say, well, y is going to be equal to 100 over x. So for any x value that you chose, for any value of your height, I could tell you exactly what this width would be. And then, since we had that, we also could figure out from our arbitrary rectangle what our perimeter would be. So we said our perimeter P was going to be equal to our two y segments, or the length of our two y segments, plus the length of our two x segments, and that was going to give us our perimeter. And because we had our y explicitly defined in terms of x, I think I made that same mistake in the last video where I said our y explicitly determined, or we have our y explicitly defined in terms of x, we are able to just replace this y in our first equation with this expression, with this 100 over x. So now we've got a function, this function p of x. This function, for any x that we choose, for any height that we possibly choose for our rectangle, and I should say for any positive height that we choose for our rectangle, we can now say what the perimeter would be just by choosing this height. If we just choose some number for our height and then plug it into our function, this is going to tell us exactly what our perimeter is. So what we want to find, and hopefully you can see, if we were going to graph this, what would this look like? And remember, at the beginning of the last video, we were talking about how we could have a rectangle that's really, really, really short, that has a 0.0001 height, and then it would have to have a length of 1 million. And similarly, we could have the inverse case where we had a width of 0.0001, and then we would have to have a height of 1 million. So you can imagine that this graph for our perimeter. So if we're trying to, our height is going to be our x value here, so that's what we're putting in. And let me just draw a real simple, actually, you know what, I'll do it off to the side here. Let's just imagine what this graph is going to look like, just so we get a little bit of an intuition as to what this function is going to do as we get really close to 0. So as our height of our box gets really, really close to 0, gets really, really infinitely small, well, our perimeter is going to get really big, right? And it's even going to, as x gets really close to 0, our perimeter is going to go to infinity, right? And we saw this in the past video where we said that when our width is 0.0001, so let me actually scroll back over here. Sorry, I'm scrolling all around right now, but we said that when our width was 0.0001 and our height was 0.0001, and our width was 1 million, that our perimeter came out to be just a little bit more than 2 million, right? And then the same thing happened in this case that we had, where our width was 0.0001 and our height was 1 million. We were still going to have this same perimeter. So we can see, or hopefully you can see a little bit, that this graph, this p of x graph, it's going to look something like this. So as we get really close to 0, it's going to get really big, and even it's going to go to infinity here. So as we get close to 0, and I'll just put that in, this is 0, that's our origin. So as we get really close to 0 from the right-hand side, our function is going to go to infinity. The perimeter, as we choose a really small value for our height of our rectangle, our perimeter is going to go to infinity as our height gets really close to 0. Similarly, what happens to the perimeter as we go to infinity, as x gets really, really big? Let me actually scroll over. There we go. So what happens to infinity what happens to our perimeter as x gets really, really big? So we saw that in this example that I'm kind of hovering over right now, where we had our height was 1 million. Well, our function is also, our perimeter is also going to go to infinity. It's probably not going to go to infinity at the same rate that it goes to infinity as we approach 0, but still it's going to go off to infinity. So hopefully you can see that at some point in between, we are going to have a minimum point. We are going to have a point where we are going to be able to draw a rectangle that is going to have an area of 100, but is also going to give us the smallest perimeter. So this is what we are trying to find. And what is the important thing about this point? And this is really the big calculus step of this problem. Hopefully you can see that the important thing about this point is that the slope of our function at this point is 0. So the slope, if we were to draw a tangent line, it would look like that. It would have a slope of 0. Slope is equal to 0 of this line. So how can we find that? Well, we've got our function. We've got our perimeter explicitly defined in terms of x. Let's just take the derivative, and then we can set our derivative as being equal to 0, and then just solve for x. So let's just go ahead and do that. So let's take p prime of x. Let's switch colors. So here we go. Find p prime of x. And we can simplify. This is 200 over, and we could say that this is 200 times x to the minus 1, right? So we could say that this is going to be, what is that? This would actually be minus 200 over, and actually here, let me just write this a bit clearer. So this is going to be, p of x is actually going to be 200x to the minus 1 plus 2x. That's a form that will help us take the derivative, maybe be a bit more helpful. So this is going to be 200 times minus 1, and then we decrement this exponent by 1. So it's going to be minus negative 200 over x squared. And then the derivative of 2x is just going to be plus 2. And now we can set this as being equal to 0. So 0, because we're trying to find the point on this line, we're trying to find the point of our function where the slope is going to be 0. So we're going to set our derivative, or the slope of our function, as being equal to 0. So you have minus 200 over x squared plus 2. And now we just have to solve for x, right? So let's go ahead and just get into it. So this is going to be, we can subtract this 200 over x squared term from both sides. So we get 200 over x squared is equal to 2. And then I'm going to move all of this up here so we can save space. So now I'm going to multiply both sides by x squared. So we get 200 is equal to 2x squared. Divide both sides by 2. We get 100 is equal to x squared. And now we just take the square root of the whole thing. And we find out that our x value, or you could say that our height that we're looking for, it's going to be either plus 10, or it could also be minus 10. And hopefully you can see that this minus 10, we should put this in. We can say that, the square root of 100 could be either plus or minus 10. But hopefully you can see that it doesn't make any sense for us to have a rectangle whose height is going to be minus 10. So we really don't have to put this value in, and we just have to pay attention to our plus 10. So this should hopefully you can see now that we have found at least our optimal height for our box. And our optimal height, so height, let me just write this down. So the height of the rectangle is going to be 10. And then what's the width going to be? Well, our width is going to be y, and we can just plug it into this function up here. So y is equal to 100 over x. So what is 100 divided by 10? Well, it's 10, right? So our width is also going to be equal to 10. And you can check 10 times 10 is equal to 100, so this rectangle, this was the rectangle that we were looking for. A rectangle of height, where the height is equal to 10 and the width is equal to 10. And hopefully you can see that this is a square. So a square is going to be the rectangle of a given area that has the least perimeter. So anyway, hopefully you found these videos helpful, and I guess I'll see you in a future video. Thanks for watching.